All right. So last week we took our first exam, and uh, I'll have the exam grades for us tomorrow. Uh, a few things have happened, like usual. I'm still getting more exams in, but also, for some reason, Hawks didn't want to give me the answer sheet yesterday when I was trying to grade them. Don't know what happened there. But yeah, I'll have those tomorrow for us. So let's go ahead and go over our exam. So number one, determine whether the statement describes a population or a sample. And it gives us the example, the amount of money each person in your chemistry class spends eating out in a week. So would that be population or sample? Population, yeah. It's not giving us any modifiers to that. It's not saying, a fourth of the class or anything like that. It's just saying the class. So this would be a population. Okay. Next. If the researchers administering care know which partakers have been placed in the experimental or control group, but the partaker does not have this information, the experiment is what? Single blind or double blind? Is what? Single blind. Good. So single blind is where the researchers know what group each participant is in, but the participants don't know, of course. And participants should never know what group they're in. A double-blind study, on the other hand, is where the researchers do not know what group the participants in, and of course the participants don't know what group they're in either. That's why it's called double-blind. There's two that don't know. Okay. Any questions? All right. Next, determine whether an observational or experimental study is appropriate to address the following statement. A car wash operator wants to find out if a need for additional staffing exists. So would this be observational or experimental? We could do an observational. In fact, I'm going to kind of throw this one out because you could get away with an observational. An experimental, though, is what I would think is more appropriate. Hire one more person and see if your volume increases, if your productivity increases, things like that. Although you could also just do an observational study and look at your current volume and your current productivity and compare it with previous months. Maybe you had more or fewer employees. So either one could be true. I would say experimental, but the case could be made for observational. So I'm going to throw this one out. It's just a free point for everybody. Okay. Next, a college administrator wants to know if the SAT scores of an incoming freshman have an effect on their end-of-year freshman GPA. The SAT scores would be considered the what? Response variable or explanatory variable? I wouldn't call it the response. The response is the thing that responds to what we're observing. Okay? So what we're observing is SAT scores. And so the response to that would be the freshman GPA at the end of the year. So it'd be explanatory. Because again, what he's asking is, does the SAT score have an effect on the freshman GPA? And if it does have an effect, that's the explanation. Does this make sense? Okay, good. Any questions? All right. Next. A mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percent of the complaints are due to the category extra data usage charges? And round your answer to 2 decimal places if necessary. Okay, so first of all, we need to find that category. It's right here. Okay, so this is the part that we're going to be focusing on. What else do we need, though? Exactly. We need the sum of all of these frequencies. We need to know what the total amount of complaints was so that we can compare the part that we're looking at to that total. Of course, that being a percent. Okay? So we need to add all these up. So 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156 gives us 790. Now, when we calculate this thing, we need to divide. But what are we going to be dividing by? Is 87 going to be on top or bottom? On top, good. Of the exams that I've seen, the one mistake that I see on this one is flipping this to have 790 divided by 87. Remember that a percent is always a part out of the entire thing. So like a percent out of 100, this should be the part out of the total. And speaking of a percent out of 100, we can equate this to that fraction and get a proportion. So we can multiply 87 by 100 and then divide by 790. Or we can divide 87 by 790 and then multiply by 100. Either way works. They're both the exact same thing. So they'll give you the exact same answer. I'm going to do 87 divided by 790 and then times 100. And that will give me 11.012. So it'll just be 0.1 then. Any questions? No? Makes sense? Good. Okay. Next, consider the following data. And it wants us to find the mean, median, and mode if there is a mode. Okay? So, we need to do what with our numbers before we do anything else? Order them. Good. So, let's see. Smallest number is negative 14, and negative 13, negative 8, negative 7, negative 5, and then just regular old 5. Okay? So now, to find the mean, we need to add these up. And we need to make sure we take those negatives into account. So negative 14 plus negative 13 plus negative 8 plus negative 7 plus negative 5 plus 5 is negative 42. And then what are we going to divide this by? 6, because that's how many data points we have. Good. So divide that by 6 and we get negative 7. Excellent. Okay, so there's our mean. How about our median? That's our middle number. So let's see. If we go to the middle here, we've got two numbers in the middle. So we need to find the number directly between negative 8 and negative 7. What would that be? What's between negative 8 and negative 7? Negative 7.5. Good. Of course, you could add them and then divide by 2 to get the same answer. Okay. And finally, the mode. What is our mode? There's no mode here. In order for us to have a mode, we need to have a number that repeats. None of these repeat. Okay. Any questions? None? All right. Next. Says calculate the GPA of a student with the following grades. They have a C in a 16-hour course, a B in a 5-hour course, D in a 12-hour course, and then it gives the breakouts for each of those grades. And it wants us to round our answer to 2 decimal places. Okay. So of course this represents a weighted mean. So the first thing we really ought to do is convert these letter grades into number grades, values. Okay, so C whoops, C is a 2.0, so that's 2. B is a 3.0, and D is a 1.0. Now, what do we need to do with these numbers now? Not quite add yet. That's the next step. Yes, we need to multiply our weights by our values. So, we'll do 2 times 16, 3 times 5, and 1 times 12. There we go. So 2 times 16 is what? If you know computers, it's 32. Okay. 3 times 5? 15. There we go. And 1 times 12? Yeah. And now we add them together. Okay. So let's see. 32 plus 15 plus 12 gets us 59. But we need another number to divide this by, and how do we get that? Do what? Yeah, so take all the hours, add them together. So how many were we trying to get out of here? So that is 16 plus 5 plus 12. 16 plus 5 plus 12 is 33. So let's see, what is 59 divided by 33? That gets us, we went around to 2 decimal places, so 1.79. Not a great GPA. Okay. Any questions? Yeah, D may be for diploma, but not much of one. All right, next. For the graph shown, determine which letter represents the mean, the median, and the mode. Letters may be used more than once. Okay, so first of all, which one is the mode? B, yes. Remember that this kind of graph shows us frequency. Okay, so as this graph increases, the frequency of these numbers is increasing as well. Well, here is the peak. And so if this is the highest frequency number, that means it's the number that is occurring the most. So it has to be the mode, B. Okay? How about, what is C then? The median. Good. The median, in this case C, splits our frequency chart, or our frequency graph, into 2 equal pieces. So on this side we should have 50% of our data, and on this side we should have 50% of our data. The reason it's not in the physical middle right now is because the data isn't distributed evenly. If it was distributed evenly, then our median would be directly in the center. But since it's skewed to this direction, the median is also skewed towards that direction. All right, well, the last one's pretty obvious. What's the mean? Yep. It's always on the other side of the median from the mode. Good. Any questions? Nope. Okay. Next. Calculate the value of the sample standard deviation and the range for these numbers. Okay, and so I took out the variance from this one, but of course we're going to calculate variance on the way to standard deviation. So, whatever. So we need the formula for standard deviation specifically for a sample here. And that is S equals the square root of the sum of x minus what? The what? The mean? Yeah. So what is mean for a sample? What is that called? X bar. Excellent. Good job, both y'all. Squared all over what? N minus 1. Perfect. Excellent. Now, why is it N minus 1? Because it's a sample. We don't have all of the data points for the entire population, and we need to take that into account. That's why we take 1 off of that N. Okay. So, let's go ahead and see what we get. Of course, remember, we need the mean and the N in order to calculate this. Well, N's pretty simple. What is N? 6. And so we can use that to get our mean now. All right, so we'll just add all these numbers up. Let's see, negative 5 plus negative 15 plus 3 plus 3 plus negative 5 plus negative 5. And we get negative 24. Divide that by 6. And we have an x bar of negative 4. Okay. So now we can take these, put them into our formula, and work our way through it. Of course, the first thing we need to do is x minus x bar. So each of these x values is going to get this taken away from it. Now remember what that means is we have something like, for this first one, negative 5 minus, for this minus right here, negative 4 right there. So what does this double negative do? Becomes positive. So really this is negative 5 plus 4. What's that going to give us? Negative 1. All right, so we're going to need to do that for all of these. Negative 15, really plus 4? Negative 11, good. 3 plus 4 is what? 7. And same thing here, negative 5 is still going to give us negative 1. All right, so there's our x minus x bar, excuse me.
Is it still going to be the same because they get only positive numbers though?
Excuse me?
It's still going to be the same for the positive numbers though?
What do you mean?
The negative, I'm confused.
Okay. So yeah, you're talking about the plus here?
Right.
Yeah. So remember, this is the sign that we're talking about for each of these numbers. If it's positive, this is still going to be a double negative because we have a minus there and a minus there for our mean. So
Right.
that gives us a positive for each of these. Basically, a negative mean is always going to be plus. A positive mean is always going to be minus. This flips the sign of this, in other words. Okay. So now, we need to square all of these values. So negative 1 squared is what? 1. Negative 11 squared? 121, good. 7 squared? Good. I'll fill in the rest of these since they're just repeats. Okay, now we need to sum all of these and see what we get. So 1 plus 121 plus 49 plus 49 plus 1 plus 1 is 222, and we need to divide that by n minus 1. So what's our n minus 1? 5. And we get 44.4. Now, what does 44.4 represent here? Is what?
It's our, yeah, it's our variance.
Variance, yeah. So it's our sample variance. Now we need to take our square root and that should give us our standard deviation. So if I take the square root of 44.4, that gives me, run to one decimal place, that is 6.7. Okay. And now the range. So what is our smallest number? -15, and our largest number? 3. Okay. So think about it on a number line. Range is a distance. We need the distance between this and this. So what is that distance? Is what?
No, I'm thinking that one.
Okay, so what's the distance from here to here? 3. What's the different distance from here to here? 15. So it's 15 plus 3. 18. Okay. Oh, any questions? All right. Next. And actually the last one. Okay, suppose that a company wishes to predict sales volume based on expenditures. The sales manager thinks that the sales volume and advertising expenditures are modeled according to the following linear equation. Both sales volume and advertising expenditures are in thousands of dollars. Let's keep that in mind. Okay. So our linear equation is estimated sales volume equals 49.48 plus 0.51 times advertising expenditures. In other words, if we spend a certain amount of money on advertising, we should get a certain amount back in sales volume. Okay? So, if the company has a target sales volume of $225,000, how much should the sales manager allocate for advertising in the budget? Round your answer to the nearest dollar. Okay. So, we're going to plug this in where? For what? Sales volume. Good. Now, are we going to plug in 225,000? No. What are we going to plug in? 225. Good. Because 225 is how many thousands of dollars we have. And remember, these are in thousands of dollars. So, 225 equals, let's see, we have 49.48 plus 0.51 times advertising expenditures, which I'll just call A. Okay. So now we need to solve for A, in other words, get it by itself. So what's the first step we can take in doing that? Good. Subtract 49.48. We'll do that from both sides. Of course, we need to preserve that balance on the equation. So this will cancel. Now let's see what we get here. So 225 minus 49.48, and we have 175.52. So now we need to bring down the rest of our values, which is 0.51 times A. All right. One more step. What do we do? Divide. So 0.51 is coming off of this thing. Same on the other side. Cancels there. Let's see what we get. It should be a larger number than this. So divide by 0.51. And we get 344.7 if I round. Okay. Is this my answer? No. What do I need to do to it? Put it in what? Do what? How? Where is that decimal going to go? Yes. So, in other words, we need to take this. Right now, it's showing us in thousands of dollars. We need to multiply it so it's in just a regular number form. In other words, multiply it by 1,000. So our real answer is $344,157. Okay, any questions? None? Makes sense? Okay, how do we feel we did on this exam? Decent? Okay? Terrible? I hated it? Okay, as long as no one has that answer. Yeah, I have looked at most of the exams already. I was looking at them while I came in, and they look pretty good. I think we did a good job studying for this one. Okay? Again, I'll have those grades for us tomorrow. I'll be sending them out through email. All right, so I'm going to allow Professor Lamar to lecture tomorrow, and then I'll pick up her lecture on Wednesday. Okay? So today, I think that'll do it for us, and I hope you have a good day.